Next, I'm pleased to introduce to you someone many of you already know. He's been with us for a few years now, Marcus Weldon, the CTO of Nokia and also the president of Bell Labs. Yes, the Bell Labs. It is a different place than it was in the 40s and 50s when they were playing with monopoly money, as they specifically were playing with monopoly money at the time. And a couple of interesting points. As I mentioned yesterday, we were in Finland recently. Nokia, though we don't see them on our handsets, is actually doing quite well right now. They remain a $30 billion a year company, and one of the seats of this resurgence has been Bell Labs and much of the work that Marcus Weldon is doing. And one last thank you. When we were putting this together and I was reaching out to people about our transition out to the world, Marcus was on my list, and within a 15-minute phone call, he said, "We want to be part of this. Sign me up." With that, Marcus Weldon.
The magic clicker. Thanks, everyone. It's great to be here in the twin community. I am going to talk about our journey. That was a great panel to start with, because Bell Labs is a bit weird in that it is the purpose of its parent company. Now, they may struggle with that purpose periodically because, of course, there's always business pressure. But every parent company, which has been, I've got AT&T, Lucent, Alcatel-Lucent, now Nokia, as the Finns like to say, has inherited Bell Labs, and not by accident. They've actually used it as a crown jewel. They've often put it in the name, etc. And the reason is it's the better purpose, the higher purpose of the company. And it's weird that we found 4 parents who believed in that, but I actually believe fundamentally corporations want a higher purpose. But the trick with Bell Labs is you get to inherit it, and that's important. It's very hard to start a Bell Labs, because I'm going to show you how it works. You start by thinking 10 years ahead. So if you want to develop a Bell Labs, you have to be prepared to get nothing for 10 years. But of course, if you've been in existence for 92 years, you've got lots of backlog. And so the new parent gets to inherit a backlog, which makes it much easier to justify the investment because you're getting good stuff every year. So that's sort of the secret of Bell Labs. But it really does. Bell Labs has a humanistic purpose, which is the really interesting thing. And although it's shifted a little bit over the years, I'm going to try and convince you it's still the same in many, many, many ways. So we're going to go through that journey, and we're going to end up back at the arts where we started this morning, because one of the purposes of Bell Labs is actually to interact with the arts, and I'll explain why that is. So here we go. I thought I would be, there it is. The boldest title is "The View from the Labs is How to Transform Human Existence." That's a pretty lofty purpose. And it's not an arrogant thing. It's actually, we feel it's an obligation to help humanity transform using technology, but that's what we're going after. So I'm going to explain how we do it, what we think the big shifts are that are coming, and then some of the projects we're working on. I'm going to do that all in 20 minutes. If I achieve that in itself, that is a remarkable accomplishment, and those who know me say it's incredibly unlikely that's going to happen. But let's start with this one. So this is from the 1920s. So Bell Labs, 92 years old. Started on West Street in New York. That's the original building. We outgrew it. We're now in New Jersey and 11 other major sites around the world, including Finland. But the highlighted text there says, "A development is undertaken to meet a recognized need, directed towards the major problems of telephone and telegraph communication, but out of that arise many interesting byproducts," and then we do a bit of science as well. But the science is actually, although it's written that way there, the science is done only to solve the problem that you've identified. It was never, and it's a misconception that we were an academic-like institution. We were maybe for 10 years in the 80s, when AT&T didn't really have a purpose anymore. It had invented, it seemed, everything you needed for telecommunications. This internet thing was happening, but it wasn't a big deal, so you might as well just carry on doing what you're doing. And then maybe Bell Labs was a little academic, but actually every side of it, every decade either side of that, it always was solving real human need problems, trying to help people communicate and network better. And we only did the science we needed to solve those problems. Now, we did neural networks, we did biology, we did chemistry, we did physics, because all of those things needed to be done to solve those problems. But we still do that. So Bell Labs hasn't changed. That's the purpose. We actually think 10 years ahead. I'm going to show you roughly the methodology and try and solve the problems that prevent us from getting to the next phase of human existence. So here is our modus operandi. Same thing. I actually inherited some of this from my predecessors. There have been 13 of me. I feel like Doctor Who in some ways. Some are better looking than others. But this is how Bell Labs roughly works. We think future back. So first of all, ignore the present. it's not going to be for long we ignore the present, but we start by saying, pretend the present isn't the limit, and that the products our parent company owns are not the limit of what you could make. So we start thinking future back and imagining human needs. We don't think commercial needs, human needs, okay? Then the second one I put in the list is maintaining contact with the market, which is actually where it's an advantage to have a business, because you actually know what the market is, so now you know the current constraints. Now you match those two. Okay, so you match that, where should we go, where are we now as an industry, not just what do we make. You attract the best and brightest, critical, you've got to have really smart people, but it's inventors and implementers, so it's not just the geniuses who think, it's actually really good doers, because we have to build prototypes, we have to do real stuff, right? And diversity of perspectives and countries and genders and whatever, that's all maximally important, because the secret of Bell Labs is not 1,000 brighter people than any of you. I doubt that's true. You look pretty smart. But it's actually 1,000 people interacting creates a hive that is better than any one of those individuals, so that's critical. It's a meritocracy. Only the best idea matters. Don't care where it comes from. I interview everyone who joins Bell Labs so I can make an immediate connection, and then we can move forward together, and I spend as much time talking to those people as I do to people like Larry who work directly for me. So that's it, right? And then we want to challenge limits, because we want to do big, important things. And it's not just for commercial ambition. It's actually for human ambition. We like, therefore, disruptive things, not sustaining things. Our businesses tend to do sustaining things. Our job is to disrupt and get ahead of them so that they can do something different in future. And then our success ultimately is measured by long-term impact, not short-term financial gains. And that's the hardest part for the company to stomach. But on the other hand, back to where I started, since we've been doing it for so long, every year they're getting short-term financial gains, but every new project we start is 10 years out. That's actually the secret. It's hard to start a Bell Labs because you need to give it 10 years to produce anything. But if you've had one for 92 years, it's already producing. Okay, so it's important. So these are the things we've done. We've invented most of digital society, if you want, the transistor, solar cells, radio communications, optical fiber, Unix, C, C++, wireless communications, fixed communications, radio astronomy, digital signal processors, silicon photonics. Pretty much everything that you use and a lot of the stuff inside your smartphones is Bell Labs technology. Now, people consider it a failure that we're not therefore the size of Apple. But in fact, it was all, or a lot of it was invented in an era where, in fact, the licensing agreement, because it was owned by a monopoly, was it had to be made free of charge as a royalty-free license of the technology to all and sundry. So therefore, in fact, it had to be put in the public domain. So that's actually why it isn't this sort of behemoth of business. And it's had to have sequential parents to sustain it. But that's what we've done. In the process, we have happy accidents. Happy accidents include Nobel Prizes, National Medals of Science, Japan Prizes, Turing Prizes, Emmys, Oscars, Grammys, and Marconi Awards. But they're completely accidental. We're sort of surprised when it happens. But it's because we essentially went to the limit, solved problems that were previously considered insoluble. We kept going because we needed to solve the problem, because we needed to invent a new form of communications, networking, whatever it is. So these are our happy accidents, and we continue to win these. Our last one, we won Nobel Prize in chemistry 3 or 4 years ago for a new form of microscopy that turned out to be very useful in biological analysis. It was called superluminescent microscopy in the near field. You think, what the hell were we doing? We were looking at laser structures with that, and then the individual realized it could also look at light-emitting molecular structures if you could get molecules to emit light. So that's the type of thing where it's a happy accident. So I want to just compare and contrast so you understand the different models that exist for innovation. And I've highlighted sort of the Bell Labs model relative to startups, academia, and industry. So we obviously have corporate R&D, so let's start there. That's what the company does. And it generally has a 1 to 3 year horizon. By the way, if you don't know the definition of innovation, the simple definition is invention and implementation. I actually add in market need, because it's pointless if you implemented something that no one wanted. And of course, marketing means that you can convince them they wanted it when they didn't. Great marketing does that, but maybe not the... So anyway, we'll go with these three of invention, implementation, and market need. So, and it's important, the market need one is the one that academia doesn't get, right, because they don't actually know what markets need. So corporate R&D, 1 to 3 horizon, generally the invention. It's incremental, generally, and it's a single application. You generally focus on one goal. But I think about academia, the other end, 10-year horizon, so way further out, but don't really implement anything, maybe a proof of concept or a simulation, and disconnected from reality. We hire a ton of PhDs from academia, and they always say they're coming because they're fed up with doing irrelevant things. And it's not that they're irrelevant to the larger human purpose, but in terms of people who want to have an impact, they always say, I want to have an impact, and so I need to join an industrial lab. So let's do startups. They're actually our closest analogy or analogous funding model. They have roughly the same horizon, 5 to 10 year horizon. I'm going to assert that they actually don't start with technology. They start with a business that they want to disrupt. And that's the difference. And then they tend to focus on a single application because their funding model requires sort of some return on investment within a relatively short period of time. Bell Labs, same time horizon. We focus on technology first, answering human problem. We don't think about business at all, to be honest, in Bell Labs. The company keeps us accountable for that, but we don't think about that much. And we try and solve for multiple applications. I love the earlier point that way we work, and there's a famous paper that you should read if you want to understand Bell Labs by Richard Hamming, who was a very famous Bell Labs scientist. But he invented many, many, many things. And so people asked, why did you keep changing what you did and invent a new field? And he said, frankly, because he saw his purpose was to actually maximize his output, not become expert and a Nobel laureate in one field. He actually derided the Nobel laureates as essentially becoming trapped by their own fame. And his view was you should change what you do every 5 to 7 years, which is what he did. And the way he did it every time was take a specific problem that he would run around the lunchroom to find out what the problem was. And if you couldn't convince him you had an interesting problem, he went to the next table. Then generalize it. What is the general solution to that I can reuse? And then with that general solution, you had to prove you could solve the original problem. In other words, you can't just be sort of airy-fairy and nebulous. It had to be real. And he did that over and over again. So that's what I mean by multiple applications. We try and generalize. And we can because we have that 10 years. Now, you could argue maybe this is flattering to Bell Labs. The one we struggle in that I didn't put in is execution. A startup actually might be better at executing than us, meaning into product, because our businesses only do certain things. So that's where we end up licensing the technology to others. So that's how that works. So that's the model. Now, I want to talk about a shift now for the last 9-10 minutes, the shift we see, and then I'll go quickly through a bunch of things. If you think about it, we're in the business of communications and computing. That's really what Nokia or Bell Labs does. And you can see if you look at this, and the way to read it is these are the value elements in communications and computing. And as we know, Apple merged them. So I start with computing, then I go to personal computing, then communications, the Nokia phone, then the smartphone, which is a merging of a computing and a communications device. But every 10 years, the value vectors have shifted. Blue is highly valued, gray is less valued. By the way, HMI stands for human-machine interface. Okay? So it's how you interface with the system. And you see it's been shifting every 10 years. And I'm going to conjecture that, just by assertion, that in the next 10 years it shifts again. And here's where the shift is coming. Instead of amalgamating everything in a single device, and I'm going to use my smartphone as an example. So here's the proof. And this is sort of how we think in Bell Labs. So you're going to have a Bell Labs experiment here. If I want to do augmented reality, which is one of our purposes in life, to somehow be augmented either physically, physiologically, or intellectually. Is this the right way to do it? Does anyone think this is the right way to do augmented reality? No, it's the worst way because it inputs this device between me and you, and it's obvious now I'm actually probing you in some way. You don't even know what I'm seeing, right? It could be the X-ray specs from cartoons. But the point is, this is wrong. If I want to be physically augmented, or physiologically, it's not the right device. It doesn't do any of that, right? You can have a watch, and it does some of that, but it certainly doesn't augment you more than that. So if augmented reality of humans, and I don't just mean the AR of popular culture, is the answer, this is not the answer. Okay? So what is the answer? We think it's devices that look like this. We're actually building this device and a bunch of others. I'll show you at the end of the talk. But it's a device that is more intuitive, that sees and hears for you, that feels for you, that augments you physically. But the properties of this device are that it has no OS. The OS disappears and the apps disappear because essentially it's too simple, too cheap, too infinite battery life as a requirement, that you can't have any of the higher order processing functions in this. It's basically a sensor and a radio, right? And then maybe a speaker. So what happens is you have to connect this to the cloud. That cloud has to have very high performance, but essentially apps get replaced by AI assistants who proxy the application function for you. So you're now constantly interworking these devices with a cloud-based AI system that's proxying the application. So I don't actually care about tapping on apps, downloading apps. I just proxy it all because I ask for help. right? And that's much more natural. If we think of it humanistically, that's the right way. You want a personal life assistant, both physically, physiologically, and intellectually. So that's the big shift. There'll be a whole new vista of innovation there. And in particular, you see the new things, networks matter. Why do networks matter? Because to actually constantly connect these devices with high reliability and always-on connectivity and low latency and high capacity, you need to build new networks. So that's actually what 5G is all about. I won't get into 5G today, but that's why 5G is such a big deal, because it actually solves for that sort of problem, whereas LTE does not. It's basically a broadband, sort of human web broadband, or as we call it, mobile broadband technology. So I want to put this in an industrial context, though. So consumers are not going to drive this revolution. This is the revolution, or the three industrial revolutions that have happened. And this is work from Robert Gordon, who you all know, who basically said human productivity, to get back to the point about productivity, rose tremendously in the first and second industrial revolutions and has diminished ever since, asymptotically to zero. So the internet age, the age that we think is so profound in its disruptive potential, has produced nothing of material value. It's produced what economists call utility. Your life is somewhat easier, because you can do anything anywhere, but in fact you're overwhelmed by the stuff you're being asked to do, so I'm not even sure that utility is the right word. So we actually start thinking about this humanistically. How can you solve for this? The human problem we need to solve, ignore the industrial problem for now, and I'll come back to it, is humans, and this is Maslow's hierarchy, want to spend less time doing mundane tasks, the things at the bottom, and more time doing creative tasks, the things at the top. And in fact, you see the term transcendence and self-actualization that was talked about earlier. But that's the goal. So if humans want to do less mundane and more creative cognitive tasks, that must be our purpose. So if we look at what humans actually are doing, this is data from Mary Meeker, it's shopping. Now, nothing about that. Now, maybe you could say it's self-actualizing in some consumerist way. But this is the time spent on your mobile device, your smart device. It's dominated by shopping. And if it's the amount of shopping is going up and up and up. Now, why is that? Because the platforms you're interacting with are ad-funded. And if they're ad-funded, they have one purpose. It's just to get you buy stuff. Because if you don't buy the stuff, you just look at the ads, you can't sustain the advertising model. So, of course, we're shopping because we're being forced to shop. Everything is designed to do that. That is not a higher human purpose. Does anyone think this is the ultimate purpose of humans, is to shop? But that's what the internet age has taught us. So I'm going to argue that consumers shouldn't be trusted to make this decision, right? So, and this is my favorite cartoon here, is what we've essentially done, another way of thinking about it, is we take everything that used to be good and wonderful and physical, and now we're stuck in front of a screen, and that's what we're calling progress. It's not progress. So what is going to happen? This is going to happen. If you now look at what is happening in the physical world, digital industries, the ones that finance media, content, etc., have actually achieving productivity that's Robert Gordon-like at 2.7%. But they're only 30% of our GDP. Physical industries, the ones that are mining, transportation, infrastructure related, are hardly digitized, as we all know. Our physical world is not really digitized, and achieving productivity growth of what we would have expected from the Gordon curve of 0.7%. So that's what's holding us back. And that's our purpose. Our purpose is to solve for that and do it in a way that essentially saves people time. So this is more data showing that's what automation's all about. It's a great McKinsey report. I throw it up here. It says half of work, that's the thing in the red box, is highly automatable. And the tasks are collecting data, processing data, and then physical outcomes. And I'm going to come back to that because physical activity is going to be important. The hardest job to automate is a physical job if it's not a repetitive, exactly the same sort of job that a robot can do. So those are sort of the resurgence of the blue collar, if you like, or the working class, or the non-laptop class, or whatever we call it. But in between is sensors, creating data, AI systems processing the data, a network to connect them, and then outcomes, which is sort of physical outcomes. So I'm going to now show where we're going in Bell Labs, and it'll be 2 or 3 minutes of a whirlwind tour. We like to go back to science fiction occasionally, so we're not just dreaming. So I would argue this is what we've done so far. We have, and I go Star Trek, and I'll even go a little more Star Trek in a minute. So we created the communicator. It was the smartphone. We created the holodeck. That's essentially virtual reality in more sophisticated environments. And we created the replicator, which is a 3D printer. But that doesn't seem to be enough. So what is it that we're going to do more? I'm arguing we're going here. We're going to and build the transporter. Yes, but we're going to try. But it's going to be, you see, I use the sneaky word virtual, and I'll come back to that. If you think about it, a transporter is a vision you would have if you didn't believe that you could actually capture something perfectly and then transfer that information and perspective and sentience. But you don't really need to dissolve yourself and reappear if you could experience the whole thing. So that's why I think virtual is the answer. We're going to do this. We're going to create the tricorder, which is sort of physiological augmentation so I can know my state. And then empathic communication was a famous Star Trek episode where it was hypersensory, and she would actually, the empath, would be able to absorb your pain. It's a bit extreme, but the idea is we would actually be able to communicate in a much more deep way. And we're going to do this. It's not all Star Trek. There's a bit of Tom Cruise in there as well. New human-machine interfaces that allow this to be intuitive, and I've hinted at those. So I'm going to start here.
Hey, Xerxes. Great to see you this week. This is a little recording of the good captain. It's Friday afternoon. Late flight home last night, but the Starship got in okay. So now we're going to hit the weekend, have some fun, and look forward to catching up with you and everyone else next week. Cheers. Out.
That was Shatner that was captured, but the idea was it was captured with a full motion capture. The idea is now we're working with a company that, Ziva, who produced Avatar. Yeah, and the idea is to do, the capture could be your smartphone and then could be rendered and sent. So I can send the smallest possible image, and then your voice would be the thing that adapted the face, and now I can teleport you, at least audio and visually. Now I want to teleport you more than that. I want to do it physiologically, right? So we're going to move on and talk about that. So what we are working on is these type of devices. There's a sleevey thing and an eerie thing, and the idea is they see, hear, feel you, so that then I can actually couple that to the experience you're having, and now maybe I can actually feel and hear, and I get that personal assistant that says, I know exactly who you are, I give you context. Many spouses say that this would save a lot of angst in relationships. The right answer could be provided for the context of the question, and I will say no more than that. But it actually is the first use case everyone comes up with. I wish, they say. But anyway, and the sleeve then essentially has complete physiological sensing as well as feedback and haptics, as well as gesture control, so it senses your muscle movement and your physiology. In the sleeve goes this thing. So this is a thing called an OCT, optical coherence tomography element. It looks like that at your eye doctor. You've probably put your head in it, and it looks for retinal detachment and glaucoma. But we've reduced it to a silicon photonic chip. It goes in that pucky thing, and the pucky thing goes on the sleeve. And there is an image taken that is actually your fingerprint, and you can see the sweat glands, you can see the dermis, the epidermis, etc. But even more interestingly, and there's lots of information that, you can actually see blood flow, of course, because it pulses. It takes a scan every millisecond, so it's pretty quick. But you can do spectroscopy. You can actually see glucose and cortisol and cytokines and all that. So you can actually then analyze what's going on underneath continuously. So that's the physiological sensing. And that goes in the sleeve as well. So now we're doing some thought experiments. So we're taking the idea of search, which you can argue is a memory assistant, by hyperlinking web pages that essentially, not really whether they're good or not, it's whether they're well hyperlinked is what's assessed by search engines, and trying to create perspective assistants that actually are much more based on the similarity of the data sets. So that's something we're working on, a new type of search engine that I won't talk much more about. But you see the health question, show me my relative health. Google really couldn't tell you that, right? But if you actually could do it across all medical knowledge, all information context, plus your own health data, you could ask questions like, show me my relative health. Couple more and then I'll wrap up. We're going to the moon. Why? Well, we're going to find out later why, so I will not spoil that. But the why in this case is that's our little rover. That's built by Audi, actually. We produce the radio that goes, that talks between the lander and the rover. It'll be November 19, 60th anniversary of Apollo 11 mission. And the idea is to go back to the original landing site, look around, scoop up some stuff, analyze it, live stream it back. The moon temperatures, this is the one that gets me. During the day, or when the sun is incident on the moon, it's 125 degrees Celsius on the moon. It's hot. At night, 13 days later, it's actually minus 170 Celsius. So one of the hard problems there is, can you survive 300 degrees Celsius temperature change and the whole thing not fall apart? My guess is no is the answer, but we'll find out. The mission is timed to last 14 days because we don't think the 15th day will be operative. So we're going to declare success. Anyway, that's that one. But we're also doing this with this crazy guy. So I'll play the video and then this will... So he's nutty. His name's Alex Thompson. He sails around the world single-handedly, which is some definition of insanity. But the idea is it's a really hard problem because he actually sleeps only 20 minutes every 2 hours. And so he's completely physiologically out of whack the whole time. So he says, I'm always just trying not to make bad decisions. So the whole point of those things he's wearing, which you saw with the sleeves and the eyebrows, is he'll get feedback that says, don't make the decision now, wait. Or get better sort of control of the system. He came second last time. Hopefully, he'll be first this time. All the others are French, by the way, in this race. And he happens to be English. So there might be a little bit of a personal agenda I have. But look, and the parent company sponsored that, and that was important to note. They sponsored the mission to the moon and that. And they think, well, why the hell would they do that? Because they have a purpose. They have a higher goal that they wish to achieve, even though the experiments we do on those things will be years and years and years before they come back to be businesses. So I'm going to wrap up with art, and I'm really done then. So Bell Labs invented all sorts of sound and microphone technologies, how we got the Grammy, Emmy, and Oscar. So we did these things. Stereo sound transmission. The Vitaphone is the first talkies needed to synchronize the video and the sound. That was hard. That's what the machine looked like. First text to voice was a machine with a admin and this is what the machine looks like. It was foot pedals and hand pedals that made phonemes, so you could type and it spoke. That was one of the first things. And first computer-generated graphics we did. And that all created a program that's very famous in art circles called Experiments in Art and Technology. Because artists like Warhol and Rauschenberg and Whitman came and said, what could we do at the dawn of the digital age that would be really great and crazy? And they did crazy and great things. But they were so crazy and great that no one actually paid any attention. It was really in the vanguard. They became famous in artistic circles as just a fantastic thing. So we've continued that recently. We picked it up again 50 years later and said it's time to come back to that because of that Maslow's hierarchy thing, meaning art and technology coming together to create a larger human purpose. So these are all the artists we're currently collaborating with. We have an active program here. So if you're an artist, come and collaborate. You get to use our coolest technology. We get to learn from you about how the technology should really work to change human experience. And we built this performance chamber, et cetera, that does full surround sound and AR and VR, and does massively interesting things. Reeps, by the way, created an AI version of his beatboxing that then beatboxes with him. So he does a duet with a AI-based beatboxing system. And he's the guy down the bottom there. So I'm going to end. It's about time I ended. I promised I'd go over. But here is what I want to end it. I want to end with these three quotes because I actually do think this is what we should be after, is actually improving the human condition. That's the purpose. Right, that's the grand purpose. And these were three quotes I just love. Art challenges technology, technology inspires the art. For sure, that's true. Here's old Steve. Is technology married with liberal arts, married with the humanities that yields us the result that makes our hearts sing? What better statement could there be than that? Right, and then one of my personal friends, after a certain high level of technical skills achieved in science and art, they tend to coalesce in aesthetics, plasticity, and form the greatest scientists and artists as well. Couldn't put it any better myself. So with that, you've had a whirlwind tour of the view of the world from Bell Labs, and I hope it was interesting.
Thank you very much. Marcus Weldon, as you saw, sits at the intersection between business, technology, science, arts. You can see why he's here on the stage. A second reason is, you might note if you've been paying attention to our agenda, we started with society at a high level, the first evening, even going off to space. We'll come back to that at the end of this morning. Then we moved to global affairs, looking across 4 or 5 countries and regions in the world, and transitioned to business. But this has been a gray area now between business and the experience of being human, which is where we're going now. Marcus was an essential part of that architecture.